Hello everybody, in this video I will help you with your prelim exam preparation and I will discuss paper 1 question 9 of the Gauteng 2024 prelim. Now this is the question. I suggest that you pause the video and quickly attempt the question yourself and then come back to the answer. You will note that the question counts 12 marks, therefore it shouldn't take you longer than 12 minutes. Question 1. The graphs of the derivative of g is equal to ax squared plus bx plus c, that's the parabola, and h of x is equal to 2x minus 4 are sketched below, that's the straight line. The graph of g's derivative is equal to ax squared plus bx plus c, and it is the derivative graph of a cubic function, an original function named g. Then the first dot there, the graphs of h and the derivative of g have a common y-intercept at point E. C is coordinate -2 and 0, and D, 6 and 0, are the x-intercepts of the graph of g's derivative. Point A is the x-intercept of h, and point B is the turning point of the derivative g. Line AB is parallel to the y-axis. Write down the coordinates of point E. So when you go to your graph, you will see, and they mentioned it, that E is the y-intercept of the straight line and the parabola. Unfortunately, we don't have the parabola's equation, but what we do have is, if you have a look at on top here, h of x's equation is y is mx plus c, and this one is h of x is equal to 2x minus 4, and we know that the c value is, when your graph is in standard form, is the y-intercept, and then therefore the coordinate of point E is the point 0, -4, because this one is 0 because the y-intercept, the rule is make x 0. So this is worth 1 mark. Question 2. Determine the equation of the graph of g's derivative in the form y is equal to ax squared plus bx plus c. So now they are testing us on our grade 11 work, where we have to find the equation of a parabola. So now this one, there's an equation, y is equal to ax minus root 1 x minus root 2. And let me just clear this up for you. A root is another name for an x-intercept. You also call them the zeros of the graph. So now this is the formula that you're going to use. This is grade 11 work, and there's a whole playlist on the parabola in my playlist section. So have a look at that. That's grade 11 work. But let's continue. So what we need, or what we know, is our one root is -2 and our other root is 6. So therefore, in the place of the root, we can substitute -2. Please note the use of the bracket there, and in the other root, 6. And then you can just say here, a minus times a minus is a plus, so we end with that. We also need a value for a, and we need a coordinate, and the only other coordinate that we really have now is this point at E, the point 0 and -4. So there's your point. This is the x, this is the y. So in y's place over here, we will substitute -4, and everywhere where you see an x, you will substitute 0. So then this one on the right hand side, 0 plus 2 is just 2, and 0 minus 6 is -6. And then we can say on the right, 2 times -6 is -12, and then to find a, we divide both sides by -12, and we end with a is a third. So now back into this step. This is now where we substitute a's value, a third, x plus 2, x minus 6, and then we will multiply that out, and we end with x squared minus 4x minus 12, and then in goes a third, and the final answer in the form that they wanted, standard form, y is equal to a third x squared minus 4 over 3x minus 4. And this one is worth 4 marks, and where's the marks? In this step, A's value, B's value, C's value. Number 3, write down the x-coordinates of the turning point of G. Now, G was, from the very first slide, they told us that G is the original function. Now, in fact, this parabola that you see here, this is the derivative. And this means this x-intercept there and the x-intercept there. In the original function, which was something like that, this turning point, the x of the turning point, would be at -2, and the x of the turning point would be at 6. So this is the red one here is the original function g, and when you find the derivative, then you find a parabola, but the x-intercepts of the parabola is in fact the x's of the turning points of the original function. Now they say write down the x-coordinates of the turning points of g. So they are testing whether you understand that. So the derivative equals 0, but then your answer would be at x is -2 and at x is equal to 6. Number 4, write down the x-coordinate of the point of inflection of the graph of G, of the original one. Now the point of inflection is the point there right in the middle between the two x-coordinates of the turning points of the original function. So first of all, when you have your graph like that, the original one, when you find the first derivative, then and equal to 0, very important, then you find the local maximum or minimum values, which means the turning points. And then when you find the second derivative equal to 0, then this is your point of inflection. So now, remember we have this parabola's equation from the previous slide. So there's the derivative equation, the parabola. So what we're going to do is now we're going to find the second derivative. So you find the second derivative, this 2 will go to the front, and you will subtract 1, and then there was an invisible 1, it went to the front, and you subtract 1, and you got x to the 0, which is 1. So there is in fact an invisible 1. So now second derivative equal to 0, that is your point of inflection, and then we end with 2 over 3x minus 4 over 3 is equal to 0. Let's multiply away the 3 both sides, or rather everywhere. Let's do it like that, and we end with 2x minus 4 is 0. Let's solve x. 2x is 4 and x is 2. So the x-coordinate of the point of inflection is x is equal to 2. Or there's a little trick I can teach you. The point of inflection is halfway between -2 and 6. It's always right in the middle between the two x values of the turning points. Okay, number 5, explain why the graph of G has a local maximum at x is equal to -2. Now, let me just give you the graph again. It was something that looked like that, and then this was -2 on the x, and this was 6 on the y. Now, if you look at my graph, for all the values x smaller than -2, so there is x smaller than -2, it's all those values there. Can you see what I did here? I said the derivative is greater than 0. Now you must understand the derivative means the gradient of the tangent to the function, and greater than 0 means positive. So if you go back to the graph, let me do this in green. Here at -2, or if I give you an invisible tangent there, can you see this tangent has a positive gradient? So this is why G has the local maximum at x is equal to 2, because there to the left of -2 you find a positive gradient. So the gradient of G is positive there. 9.2. Given h of x is equal to 4x cubed plus 5x. So this is a new question on its own. Substantiate whether it is possible to draw a tangent to the graph of h that has a negative gradient. Now let's see. It works like this. The gradient of the tangent to h at any point is. This means when you find, there's your original graph, when you find the first derivative means the gradient of the tangent to the function. So now, when you find the first derivative, you understand that this is going to be 12x squared plus 5. I'm not going to explain where that comes from. You know that. Use the rules of differentiation. So now, we know that this little equation over there represents the gradient of the tangent. And we must now state why this thing cannot be a negative. And it works like this. It has a positive gradient. X squared is greater or equal to 0 for x element real. This means whatever value you substitute in x's place, the square will always make it positive, therefore greater or equal to 0. If you add a 12 in front, then it's still greater or equal to 0 for any x element real. And then when you add a 5, this thing is still greater than 0. Stop. Not equal, only greater, because of 5. 5 is greater than 0. So there, in fact, this is the answer. The gradient of the tangent is always positive for 2 marks. Thank you for watching my video. If you click on the left hand corner, then that will take you to question 10 of this 2024 Gauteng prelim exam. And then in the right hand corner, you will see that I also added the playlist on calculus. There's lots of information there. So if you need more practice, then you're welcome to watch that one. And if you liked this video, please like the video.